Next, we're going to look at linear equations. Now, when we're solving linear equations, it's important to find the size of the reference angle as well as the location in order to solve for x. So the first one we're going to look at is solve the equation 5 sine theta plus 1 equals 0 on the interval x is in between 0 and 2 pi. So it could be in all 4 quadrants. So first thing we're going to do here, we're going to isolate theta. So we have 5 sine theta plus 1 equals 0. 5 sine theta equals -1, and then we divide both sides by 5. So we're left with sine theta equals -0.2. And then we're going to use sine inverse. So when we use sine inverse for -0.2, we get 0.2. I'm just going to put a note here to use sine inverse. Also make sure you are in radians. So 0.2 is our acute angle. So now we need to find the location. Because we're using the interval of all 4 quadrants, we're going to have 2 possible answers. So we're looking at sine, and it's positive in the equation. However, when we isolate it, it's negative. So where would sine be negative? So we're looking at quad 3 as well as quad 4. So our acute angle is 0.2. So for the first solution, theta is going to equal pi plus 0.2, which is 3.34. For the second solution, because we're in quad 4, theta will be 2 pi minus the acute angle, 0.2. So theta is equal to 6.08. So there's our 2 solutions. So we have theta is equal to 3.34 and 6.08. Now this time, notice we have brackets here. So we have solve the equation 4 secant theta plus 2 equals 1 on the interval 0 to 2 pi. So we have, using distributive property, we have 4 secant theta plus 8 equals 1. And now we're going to isolate secant theta. So secant theta is going to equal -7 over 4. Now, what is secant the reciprocal of? It's the reciprocal of cosine. So cosine theta will equal -4 over 7. We're now going to use the inverse of cosine. So when we use the inverse of cosine, -4 divided by 7, what do we get? So we get theta is equal to 2.18. However, this is not an acute angle. So in order to find what the acute angle is, let's think about where 2.18 would be located. So 2.18 is going to be in quad 2. So from here to here, the measurement is 2.18. How would we then find the measurement of the acute angle? Well, we know this is pi, so we would have pi minus 2.18, and that will give us the acute angle. So pi minus 2.18 is 0.96. This is our acute angle. So 2.18 is an acceptable answer for quad 2. So this is an acceptable answer because it's in quad 2. However, we do need this acute angle of 0.96 to help us find the other possible answer. So when we think of where else this answer could be, we're looking at when cosine is negative. We already looked at quad 2, so our next answer will be in quad 3. And we already know the acute angle is 0.96. So this time we're going to take theta equals pi plus 0.96, and that will give us the measurement from here to the terminal arm. So pi plus 0.96, we get theta is equal to 4.1. Okay, so we have many answers here. Okay, let's take a look at this word problem. So today the high tide in Matthews Cove, New Brunswick is at midnight. The water level at high tide is 7.5 meters. The depth, d meters, of the water in the cove at time t hours is modeled by the equation d at t equals 4 plus 3.5 cos pi over 6t. Jenny is planning a day trip to the cove tomorrow, but the water needs to be at least 2 meters deep for her to maneuver her boat safely. So how can Jenny determine the times when it'll be safe for her to sail in Matthews Cove? So first thing we're going to do, let's just draw a rough sketch. So from the graph, the water level is going to reach a high tide of 7.5. So because we're using the 24-hour period, we're going to assume that 0 is when we have the high tide. And then we can use the intervals of 6, 12, 18, 24, and so on. So we're going to assume that our 24-hour cycle, this is our t. So if we sub in 6, we get 0.5. So they're at 7.5 and 6, and then 12 is also at 7.5. 18 is at 0.5, and 24 is also here. And we're trying to determine when the water level is above 2. So this is just a rough sketch. So what we're going to do here, we're going to take our equation, and we know that d at t is equal to 2. So we're going to sub in 2 equals 4 plus 3.5 cos pi over 6 t. So we're going to solve as far as we can. So first thing we're going to do, we're going to move then the 4. So we have 2 minus 4 equals 3.5. cos pi over 6t. So this gives us -2. And then we divide everything by 3.5. This cancels out, and we're left with -0.571 equals cos of pi over 6t. So when we're looking for theta, or the acute angle, because we have pi over 6t here, we can make it easier to solve by assigning theta to represent pi over 6t. And then once we solve for theta, we can sub it back into our equation to help us find the times. So what we would do next, we would have cos theta equals -0.571, and then we would solve, and we get theta is equal to 0.962. Now, where is cosine going to be negative? Cosine is going to be negative in quads 2 and 3. So what we're going to do next, we know our acute angle is 0.96. So for quad 2, we would have theta equals pi minus 0.96, which gives us 2.18. And for quad 3, we would have theta equals pi plus 0.96. So theta equals 4.102. Now that we have theta, we're going to sub theta back in to this equation and solve for t. So we're going to have 2.18 equals pi over 6t, and we're going to have 4.102 equals pi over 6t. So now you're just going to solve for t. So you're going to isolate t. So you'd multiply 2.18 by 6, and then divide by pi, and you're left with t equals 4.17. And then we're going to do the same thing on this side. We're going to multiply 6 by 4.102, divide by pi, and we're left with t equals 7.84. Now, this is not the actual time. We have 4 hours and then 0.17 of an hour. So what would we do here? So this would be 4, and then you're going to do 0.17 times 60 minutes. So 0.17 times 60 minutes, and you get 10.2. We could round that to 10. So this is 4:10 a.m. And then we're going to do the same thing here. So this is the 7th hour, so 7 a.m., and then 0.84 of an hour. So you're going to multiply 0.84 by 60, and you get 50. So this is 7:50 a.m. So these are the two times where it will be safe to travel, the two intervals. So anywhere between 4:10 and 7:50. So when we take a look here, so 7:50 it would be around here, and then 4:10 would be around here. So this is when it's safe, when the water is above. So we would say, therefore, it is safe to travel between, so this is going to be 7:50 a.m., and then the cycle continues, but because this is afterwards, it's going to be 4:10 p.m.